Welcome to Lesson 8.3, Understanding Source Code Security Issues. In your Candidate Information Bulletin, we are in the Software Development Security domain. We are in Key Area of Knowledge B, which is Enforced Security Controls in a Development Environment. Our lesson topics are going to include source code flaws, such as buffer overflow, injection, covert channel, memory or code reviews, time of check, time of use race conditions, maintenance hooks, API security. We're going to look at OAuth, source code analysis tools, fuzzing, and software configuration management. So design flaws, inadequate code review, and poor configuration management all contribute to source code security issues. So source code design issues include, but certainly are not limited to, buffer overflows, injection opportunities, covert channels, code reuse, time of check, time of use race conditions, and maintenance hooks. Now, we've discussed a number of times from different perspectives in this course buffer overflows and injection opportunities. We're going to be adding these others: covert, code use, the TOC, time of check, time of use race conditions, and maintenance hooks in this lesson. So we're going to go through each one of these so that you get a sense for why they occur, how they occur, and what the impact is. So in a buffer overflow, the attacker overruns the memory allocated, which is the buffer, for data input and then writes the excess data into non-allocated memory. The excess data contains instructions that the processor will execute. So the exploit is insertion of malicious code, either in a dialog box, an address bar, or creating a network packet. The impact generally is elevated privileges because these are instructions that are going to be sent directly to the processor. The fix is that all user and data input buffers should be programmatically restricted to only what's expected. We've referred to that earlier as input filtering or data filtering. The second is injection. Injection is where an application accepts and sends untrusted data to an interpreter for execution or to a processor for execution. The exploit is often just a text-based entry. The impact can be data loss, corruption, denial of service, or elevated privileges. The fix, once again, is input validation, or using safe APIs, application programming interfaces, which avoids the use of the interpreter entirely or provides a parameterized interface. Now, as a security professional, you're not expected to be a programmer, but you are expected to understand these major flaws so that you can discuss these with the programming staff and that you can understand the output of any tests that are done. A covert channel is the capability to transfer information objects between processes that are not supposed to communicate. So we have two separate processes. There shouldn't be any information flow between them. A covert channel does find a way to transfer information. An exploit is usually malicious script or software. The impact will be unauthorized access to information. Because this isn't an anticipated channel, the fix is usually pretty tough actually to find it. Because it's an unanticipated channel, it really can be a challenge to find a covert channel. But the fix is going through a process called covert channel analysis. The next is memory or code reuse. A code reuse attack is just a class of a buffer overflow attack that repurposes existing executable code for malicious purposes. So the exploit is attacks chained together sequence of instructions, commonly known as gadgets, to execute the wanted attack logic. A common feature of these attacks is the reliance on the knowledge of the memory layout of the executable code. And more often than not, that's going to result in elevated privileges. So the fix is fine-grained randomization that modifies the layout of the executable code and hinders code reuse. Next is a time of use, time of check race condition. So in this scenario, the software checks the state of a resource before using that resource. But the resource's state can change between the check and the use in a way that invalidates the results of that check. This can cause the software to perform invalid actions when the resource is in an unexpected state. So in the exploit, the attacker influences the state of the resource between the check and the use, so between time of check and time of use. Impact can be unauthorized access, and our fixes are locking mechanism or to have the resource be rechecked after every use call. Next are maintenance hooks or backdoors. Maintenance hooks and backdoors are really hidden mechanisms that bypass access control measures. Now, they're generally used by programmers during the development stage to gain access to a program in case the access controls malfunction. So the exploit is to know about the backdoor and to use the backdoor. The impact is unauthorized access and elevated privileges. The fix is to make sure that maintenance hooks are removed before compiling the software. So we just went through some of the key source code issues that we want to make sure are addressed during development and certainly are tested for through the development cycle and definitely pre-production. Application Programming Interfaces, APIs, are connectors that allow applications and devices to work together. APIs are of particular importance right now because they're the backbone of the Internet of Things. This is how applications and devices are connecting and authenticating to each other. So API authentication options, including using basic authentication, base64 encoded, and TLS encryption is available, or using the OAuth protocol, OAuth 1.0a protocol, which uses digital signatures, and OAuth 2.0 protocol, which uses HTTPS, which is HTTP, with SSL, or in this case, TLS. Now, OAuth 2.0 relies on HTTPS for security and is currently used and implemented by APIs from companies such as Facebook, Google, Twitter, and Microsoft. OAuth 1.0a is more difficult to use because it requires the use of cryptographic libraries for digital signatures. However, it doesn't rely on HTTPS for security and can therefore be more suited for higher risk transactions. So you may be wondering, well, what is OAuth? OAuth stands for Open Authorization. So Open Authorization, or OAuth, is a protocol that allows an application to authenticate against a server as a user without requiring passwords or any third-party server to act as an identity provider. OAuth uses a token generated by the server and provides how the authorization flows must occur so that a client, such as a mobile application or an Internet of Things device, can tell the server what user is using the service. Code review is the process of auditing the source code of an application to verify that proper security controls are present, that they work as intended, and that they have been invoked in the right places. Source code analysis tools are designed to analyze source code and/or compiled versions of code to find flaws. Now, there are a number of open source and commercial tools available. The tools chosen should be evaluated for scalability, for usable output, and for false positive ratios. Tools do not necessarily understand context, making human review still a necessity. So we've talked about fuzzing earlier, and just to emphasize, fuzz testing or fuzzing is a testing technique used to discover coding errors and security loopholes by inputting invalid, unexpected, or random data called fuzz and monitoring the application response. So a fuzzer is a program that automatically injects data into the programmer's stack. And lastly, we want to talk about software configuration management. Source code needs to be protected from unauthorized access, inadvertent modification, sabotage, and IP theft. So source code protection mechanisms include configuration management programs that include multiple levels of access control, including dual control and separation of duties. Remember, dual control is when you need two subjects to complete a task. Separation of duties is when you extend a process out into different tasks and you have different subjects doing different tasks. Change control procedures, which are part of configuration management, bug tracking, release management, and documentation. use of a centralized source code repository that supports concurrency, check-in, check-out functions, version control, rollback, and synchronization. So that brings us to the end of Lesson 8.3, kind of a whirlwind tour of source code issues and potential mitigation techniques. So let's go through a quick review, and then we'll do our match the meaning. Source code flaws include buffer overflows, injection, covert channels, memory or code reviews, time of check, time of use race conditions, and maintenance hooks. We need to be concerned about API security, particularly in the Internet of Things, and we looked at using OAuth or open authorization. Source code analysis tools are available but should be evaluated for scalability and for output, and should also always still be combined with human intelligence. We did a refresher on fuzzing, which is the input of malformed or unexpected data packets. And we looked at software configuration management in relation to source code. So here are 8.3 match the meaning terms: buffer overflow, injection attack, a covert channel, object reuse attack, time of check, time of use, a maintenance hook, fuzzing, and OAuth. So take your time, go ahead and match the meaning or match the descriptors. So what I'd like you to do is put me on pause, take your time, match the meaning or match the descriptors. When you're ready, come on back and we'll go through these together. All right, let's look through our Lesson 8.3 terms. A buffer overflow is overrun of allocated memory. Remember, buffer equals memory. An injection attack is when the processor accepts and executes untrusted input. A covert channel is an unauthorized flow of information. An object reuse attack is malicious repurpose of code. A TOC, TOU, stands for time of check, time of use. That's a race condition. Think of it as a race between the time something's checked and the time something's used. A maintenance hook is a mechanism to bypass access controls. Generally, it's put in there by a programmer during the development cycle, but should always be taken out before production. Fuzzing is a testing technique that uses invalid data. And OAuth is the Open Authorization Protocol. So our 3 CISSP exam tips for this lesson. Code review should happen throughout the development lifecycle. Changes to source code should be done in a test environment. That fuzzing is a testing technique that inputs invalid data and monitors the response. We covered a lot in this unit, so feel free to go right back through it if you're not comfortable with all of these concepts. Thanks for joining me for this lesson. I look forward to seeing you in the next.